Hello everyone. So let's start with the first 10 questions of the DSE 2021 question paper. So in the first question, we have been given a function f of x equals to x square plus 2xy plus by square, subject to a constraint which we have to maximize, subject to this constraint that x plus y is equals to 100. So it's a clear-cut case of Lagrangian. So we have to maximize x square plus 2xy plus by square subject to x plus y is equals to 100. So if I want to do this maximization, so the best way to do it will be using Lagrangian. So I know how Lagrangian works. I'll just write Lagrangian equals to x square plus 2xy plus by square minus lambda times of 100 minus x minus y. ठीक है, अब इसमें जो मेरे वेरिएबल्स हैं दे आर गोइंग टू बी दिस लैम्बडा x and y. ठीक है, so lambda x and y. So what I'll do is simply del Lagrangian by del x is equals to 0, which implies 2x plus 2y minus of lambda into minus 1 is going to be plus lambda is equals to 0. Similarly, del Lagrangian by del y is equals to 0, which gives me 2y plus 2by plus lambda is equals to 0. And the third equation is going to be del Lagrangian by del lambda equals to 0, which just implies that x plus y must be equal to 100. Okay. Now these are my three equations: equation number 1, equation number 2, and equation number 3. So I want to simultaneously solve these three equations in order to get x, y, and lambda. तो ये अब मैं कैसे कर सकता हूँ? So the best way to do that would be, first of all, eliminating lambda from these two equations. So when I eliminate lambda from the two equations, so what I can get is sorry, this would be 2x, right? This is 2x. Yeah. So when I eliminate x, so I can just subtract this here. So what I'll get is 2 minus 2by, 2 minus 2b times of y must be equal to 0. Okay. Now for some b value is strictly greater than 1. Okay, so this entire thing is always not equal to 0. So for this thing to be satisfied, what I find is my y must be equal to 0. When I substitute this thing here, this gives me x must be equal to 100. So this clearly implies that given this condition, I should be using my x as 100 and my b as y as 0. Okay, that is the only way I can solve for this particular situation. Okay, so the final value of the minimum value of y which is attained. Okay, so minima. Now one thing is कि Lagrangian only tells you the optima. Okay, so x equals to 100. So I know that 100, 0 is an optima. But I don't know is it a maxima or a minima. So ये चीज़ देखना बहुत easy है. Any other point apart from 100, 0 should yield a higher result. So 0, 100, if you look at 0, 100, so your functional value at 100, 0 will turn out to be 100 square plus 100 square, 100 square. Whereas your functional value at 0, 100 will turn out to be 100 b times 100 square. Right, and since b is given to be greater than 1, okay, since we already have that the b value is greater than 1, so this particular thing is higher, b times 100 is higher. So obviously 100, 0 is a minima according to this Lagrangian situation. So the value v of b will basically turn out to be functional value at 100, 0, which is just 100 square, which is 10,000. So now my v of b is independent of b. So that's why v prime of b will turn out to be 0. Okay. Let's continue with question number 2. So now we have been given the situation कि there's a real valued function f defined on set of all real numbers satisfying that f of x is equals to x for all real numbers r. So if f is not the identity function, then which of the following is true? So in this case, what you can do is you can simply identify one of the functions. Okay, so f of x equals to 1 by x, it satisfies these conditions. Okay, because f of x, f of x, sorry, 2 needed, this is x. F of x is 1 upon 1 by x, which is x, right? So it satisfies this particular condition. So that's why I have a function. अब बस मुझे ये देखना है कि f of x equals to 1 by x, it satisfies which of these conditions. So it's a constant function, no. Strictly decreasing function, yes. Strictly increasing function, no. No function other than the identity function can satisfy this property. So that is also no, because I have identified one such function. Remember, identity function क्या होता है? Identity function is f of x equals to x. So yes, identity function satisfies this, but हमको उसके अलावा एक function identify करना था यहाँ पे. So that is f of x equals to 1 by x. Okay. Now let's move to question number 3. Okay. So in question number 3, we have been given a real valued function f which satisfies f prime of x equals to f of x का whole square. And it is given कि f of 2 is equals to 2, so f of minus 2 की value हमको निकालनी है. Now, what kind of function can become square of itself when it is differentiated? So, one particular type of function is reciprocal function. For example, 1 by x अगर मैं लूँ, ठीक है, so इसका square becomes minus 1 by x square. ठीक है, so the power basically doubles in magnitude. ठीक है, forget the negative sign right now. So I have an idea in my mind कि कोई एक function हो सकता है which is of the format. So we are going to assume f of x to be equal to a upon bx plus c. So this is the type of function that we are going to assume for now. ठीक है, so इसका मतलब क्या होगा? इसका मतलब होगा f prime of x will turn out to be minus ab upon bx plus c whole square. ठीक है, अब मुझे क्या चाहिए कि this f prime must be equal to f of x का whole square, which is basically a square upon bx plus c का whole square. ठीक है, so when I compare these two conditions, मुझे ये पता चलता है कि one thing is numerator same होना चाहिए, which implies that b must be equal to minus a. ठीक है, so when I substitute that in the original function, I get f of x must be equal to a upon minus ax plus c. So this is the format. So अब बस दो unknowns बचे a and c. Okay. So now another thing is f of 2 is equals to 2. So what is going to be f of 2 की value? So f of 2 is equals to a upon minus 2a plus c, which is equal to 2. Right. So this implies, if I rearrange this particular thing, what it gives me is that a is equals to minus 4a plus 2c, which implies c is equals to 5 by 2 times of a, which I again put in the original function. So what I get is f of x is equals to, or rather in this जो एक derived function मैंने already बना लिया है, मैं उसमें substitute कर देता हूँ इसको in this one. So f of x is equals to a upon minus ax plus 5 by 2a. या फिर if I multiply both the numerator and denominator by 2, it becomes 2a upon minus 2ax plus 5a. So this is my f of x function. Okay. अब इसमें से a मैं cancel कर सकता हूँ because a is common everywhere. So by cancelling a, what I can get is 2 upon 5 minus 2x. Okay. Now finally I want to find functional value at minus 2. So f of minus 2 is going to be equal to 2 upon 5 minus 2 into minus 2. So that is 2 upon 5 plus 4. So that is 2 by 9. So the correct answer here is 2 by 9. None of the option matches 2 by 9. So this is actually wrong. Okay. So यहाँ पे you can actually check this function to be satisfying these two properties. So if you want, I have given the link of the proof key this particular function matches the two properties in the description. So you can go and you can check it out there. So yeah, so this question has none of the options matching. Alright, let's move to fourth question. So in the fourth question, we have the summation 100C to R. Okay, अभी 100C to R is going for all the R values which are even. So this is basically equal to 100C0 plus 100C2 plus 100C4 plus so on till 100C100. So all the even powers. Okay. So for that, first write down 1 plus 1 का whole square का expansion. So binomial expansion of this thing, sorry, 1 plus 1 to the power 100 का expansion. This is going to be equal to 100C0 plus 100C1 plus 100C2 plus 100C3 plus 100C4 and so on till 100C100. Okay. Similarly, in similar vein, write down 1 minus 1 to power 100 ka expansion. So this is going to be 100C0 plus minus 100C1 plus 100C2 minus 100C3 plus 100C4 plus, sorry, इसके बाद minus होगा, and then finally plus 100C100. So as you can see, terms cancel out. These two terms cancel out, these two terms cancel out, and so on. So all the odd terms will cancel out. So the summation of these two things is 2 to power 100 plus 0 to power 100. Okay. This is equal to twice into 100C0. So only the even terms will remain. So 100C0 plus 100C2 plus 100C100. So this implies 2 to power 100 is what you are looking for. So if I call this sum as S, so S is equals to 2 to power 100. Sorry, 2 times S is equals to 2 to power 100, which implies S is equals to 2 to power 100 divided by 2, which is 2 to power 99. So that's your correct answer. Alright, let's move to question number 5. So suppose that n participants with distinct names arrive for a conference. The organizers have prepared name tags for all of them, but by mistake allocate name tags randomly to participants. So पहले तो एक tags बनाए हैं उन्होंने, tags going from T1, T2, T3 से लेके Tn, and then there are participants P1, P2, P3 and so on till Pn. Now what they have done is, instead of giving them to the individual participants, they have randomly allocated. So ये tag could have gone to this, could have gone to this person, this to this person, this to this person, and so on. So this has been randomly allocated. Okay. So ये बहुत classic case है. You can Google up the case of matching envelopes with letters. ठीक है. So envelope and letter matching ऐसा कुछ Google कर लीजिए. Envelope and letter matching. So instead of envelopes and letters, okay, instead of putting the letters in the correctly addressed envelopes, you are allocating tags to people. So it's a similar question. So they have asked the expected number of participants who will receive their own name tag. Okay. So यहाँ पे let's create a random variable n1 which takes a value 1 if P1 gets T1 and it takes a value 0 if P1 does not, और rather otherwise लिख देता हूँ यहाँ पे, otherwise, ठीक है. So अगर tag 1 person 1 के पास जाए, so what happens is this n1 random variable takes a value of 1. ठीक है. So अब ये n1, what type of a random variable is n1? So n1 is a Bernoulli random variable. ठीक है. Bernoulli random variable के अंदर एक पैरामीटर होता p, which is the probability of it taking a value 1. So what is this probability that this n1 takes a value 1? So this probability is 1 by n. Because the first tag could have gone to any of the n persons with equal probability. So the probability it goes to its actual owner, that is person 1, is 1 by n. ठीक है. So n1 takes a value 1 with 1 by n. Similarly, n1 है, n2 है, n3 and so on. So the number of people, ठीक है, so the number of participants who will receive their own name tag, let me call this as capital N. So capital N is nothing but summation ni going from, actually n1 नहीं लेना चाहिए, इसको m1 ले लेता हूँ to avoid confusion. So summation mi going from 1 से लेके n. ठीक है. This implies expected value of, so अभी capital N क्या है? Now this is basically a binomial trial. With parameters n and p होते हैं. So यहाँ पे n and p is 1 by n, which is coming from here. Right. So this is now a binomial random variable. So the expected value of a binomial random variable is n into p, n into 1 by n. So that is equal to 1. ठीक है. So if you don't know, अगर इसमें कुछ समझ में नहीं आया है, so you can always Google envelope letter matching. And you will get a lot of results, probably even my results. So I'll try to give the link of this video in the description. Okay, or maybe you can just click the I button जो ऊपर आ रहा है, so इससे भी हो जाएगा. Okay, now question number 6. A right angle triangle has two equal sides of 1 inch. One of these sides drawn horizontally is divided into n plus 1 equal portions. Okay. On each portion of the first, a rectangle is formed with the height equal to the vertical distance. So यहाँ पे हो ये रहा है कि एक right angle triangle बना लेते हैं पहले तो. In fact better रहेगा कि मैं square बना लूँ एक. ठीक है. And then in this just consider this bottom left triangle. Now what they are saying is कि n plus 1 equal parts में इसको मैंने divide कर लिया है. So I have divided this in n plus 1 parts here like this. And on these n plus 1 equal portions, a rectangle is formed with height equal to the vertical distance from the left hand end portion of the hypotenuse of the triangle. So यहाँ पे height is very crucial. Height equal to the vertical distance from the left hand end portion of the hypotenuse of the triangle. Okay. So यहाँ पे इस पोर्शन की हाइट कितनी होगी. So ये अगर मुझे जानना है इस पोर्शन की हाइट कितनी लूँ मैं. So this is the height of the rectangle. So पहला rectangle मेरा क्या होगा. पहला rectangle मेरा would be this one. So this is the first rectangle. Okay, similarly second rectangle would go here, third rectangle would go here, and so on. So इस टाइप से चल रहा होगा मेरा, and so on. ठीक है, so this is what my rectangles look like. And now I want to find the sum of rectangular areas and its limiting value. So limiting value तो बहुत easy है. This is 1, this is 1. So the limiting value, as you keep on increasing n, this is basically integration. ठीक है, so this is basically integration. तो ये सब area under the curve मैं निकाल रहा हूँ यहाँ पे. So the larger I take n, the closer it becomes to the area of the triangle. The area of the triangle I know is equal to half into base into height. So one thing is clear कि या तो ये सही होगा मेरा या फिर ये सही होगा. Okay, so either n upon twice into n plus 1 or n plus 2 upon twice into n plus 1. ठीक है, ऑलराइट. एक सेकेंड, ये चीज़ मुझे, आई थिंक दिस इज समथिंग आई हैव डन रॉन्ग. इट शुड एक्चुअली बी इक्वल टू द लेफ्ट हैंड पोर्शंस. लेफ्ट हैंड लिखा है ना, so it should actually be these rectangles. ठीक है, so these are the rectangles which I need to be calculating. This, then again this, and so on. ठीक है, so these are the rectangles which I need to be finding. So what is the area of the first rectangle? Area A1. So area A1 is, this is 1 upon n plus 1 because there are 1 upon n plus 1 equal parts. So this length is 1 upon n plus 1. And the height of the first one, height, so 1 upon n plus 1 is the base, and the height is 1 minus 1 upon n plus 1. ठीक है, because this length is 1 upon n plus 1. Similarly area A2 अगर मैं निकालूँ, area A2, this will be equal to 1 upon n plus 1 because again this is 1 upon n plus 1. ठीक है, इसको green से निकाल लेते हैं. 1 upon n plus 1, that is the base, into the height. So the height is has now fallen by twice of 1 upon n plus 1. So 1 minus 2 upon n plus 1. ठीक है, so that is your area A2. So similarly you can find any number of areas. Okay. So the final thing, AN, which is the last one, AN is going to be equal to 1 upon n plus 1, yeah, into 1 minus n upon n plus 1. ठीक है, so that is the last one. So in sub areas को when I sum, I get my total S. So S is sum of all these areas. So 1 upon n plus 1 तो common है. ठीक है, into the other part is just going to be n minus summation k upon n plus 1, k going from 1 से लेके n. ठीक है, so that is your summation. अब if you can solve this summation, you will get your value of S. So what is that summation value going to be? So 1 upon n plus 1 into n minus 1 upon n plus 1 into summation k. So the sum of first n natural numbers, so n into n plus 1 by 2, right? So first natural numbers का sum is n into n plus 1 by 2. So into n plus 1 divided by 2, right? So n plus 1 से n plus 1 cancel. So this is n minus n by 2. So this turns out to be 1 upon n plus 1 into n minus n by 2. So that is n upon twice into n plus 1. Okay, so n upon twice into n plus 1, so that's your correct answer. So in दोनों में से n upon twice into n plus 1. Now one thing which I really disliked about this particular question is कि when you take your rectangles like I had taken earlier, so in that case you get this to be the correct answer, which could have been a really bad thing for students in this particular exam. So if you're somebody who actually did this mistake and got question number 4, please write it in the comments so that we know that yes, this happened to some of our students. But this is bad coming from DSE क्योंकि यहाँ पे this language is very vague, height equal to the vertical distance from left hand end portion. So if you take it, take the rectangles like this, one option matches. If you take them like this, another option matches. So that's really unfair for students who have done a mistake in misreading this particular question. Alright, let's move to question number 7th now. Right. So in question number 7th, we have been given a summation and we have to find which of the following is true. Okay, so y का ये जो summation दिया है मुझे, if I expand this, this looks like y is equals to x minus x square by 2 plus x3 by 3 minus x4 by 4 and so on. Okay, which is basically the expansion of log of 1 plus x. Okay, so it's nothing but the expansion of log 1 plus x. So you can Google the expansion of logarithmic series. So if you just Google log 1 plus x expansion, right? So if you just Google log 1 plus x expansion, you will get the expansion of all these series, which are very important. So sin x expansion has never been asked, but the expansion of log x plus 1 and other things. So as you can see, expansion of e to power x and expansion of log x plus 1. So these are important things which you must know. So if you don't know, just Google them. एक formula sheet maintain करो. This is what I keep telling to my students also, and they do that. Maintain a formula sheet in which you write down these expansions. It's very crucial that you remember them. ठीक है. So log 1 plus x का expansion है ये और कुछ नहीं है. So this is your value of y. Y is equals to log of 1 plus x. So if y is equals to log of 1 plus x, what this implies is that 1 plus x is equals to e to power y, which implies x is equals to e to power y minus 1. अब e to power y का expansion क्या है? So e to power y का अगर मैं expansion में जाऊँ, if I bring back that particular page which I had opened, yeah, so in this very formula sheet you also have this thing कि e to power x का expansion is x to power 0 by 0 factorial plus x to power 1 by 1 factorial, x to power 2 by 2 factorial and so on. So that is e to power x का expansion. So you can write it down here, e to power x का expansion. So e to power y का expansion will basically turn out to be, yeah, e to power y का expansion will turn out to be y to power 0 upon 0 factorial plus y to power 1 by 1 factorial plus y to power 2 by 2 factorial and so on, whole minus 1. So that is basically y by 1 factorial plus y square by 2 factorial plus y cube by 3 factorial and so on. Okay, so y to power k by k factorial going from 1 से लेके infinity. So that's your answer, option number 3. Okay, now let's move to question number 8. So in question number 8, we have a vector space R to power n for some n greater than equal to 2 over the field of real numbers and the following two statements. Okay, so v1 v2 से लेके Vn are linearly independent, then V1 plus V2, V2 plus V3 and so on, and Vn plus V1 are linearly independent vectors. Okay. Okay. So first of all, यहाँ पे एक बहुत simple trick है, that if you take only two leg vectors, suppose n is equals to 2. So what is statement A saying? Statement is one is saying V1 and V2 are linearly independent, and statement B is saying V1 plus V2 and V2 plus V1 are linearly independent. ठीक है. So statement A can be true, but statement B does not become true because these are basically the same vectors. So for n equals to 2, statement B becomes false. ठीक है. So let's look for options in which n equals to 2 renders statement B as false. So A implies B and B implies A. So this cannot happen because n equals to 2 is one of the valid cases according to what's given in the question. So I just want to find that simple information कि n equals to 2 पे statement B becomes false is ruled out in any of these options. So यहाँ पे ये बोल रहा है कि A implies B, but that cannot happen. B तो false है, so that's why option 1 is wrong. Now A implies B if n is odd. B always implies A. So again यहाँ पे हम लोग इसको भी रिजेक्ट कर देंगे क्योंकि ऑड के केस में बात कर रहा है. मुझे चाहिए था कि इवन के केस में रिजेक्ट हो जाए. Now A implies B if n is even and sorry, let's come back to question number option 2. So this is true क्योंकि मुझे odd के केस में ये true है, even के केस में मुझे reject करना है. Sorry. Yeah, so I want to, so in the case of odd, A implies B is true, B always implies A, so that is correct. ठीक है. So अगर ये true है तो फिर the opposite is correct obviously, because n equals to 2 के केस में statement B itself is false. Alright. So here I don't know the veracity of this, but at this point I cannot reject option number 2. ठीक है. So I am not saying कि इसको prove करो, I am saying basically reject options. So we are trying to reject the options. Now A implies B if n is even and B always implies A. So n is equals to even, मतलब n equals to 2 के केस में हमने चेक कर लिया कि A does not imply B. So this is false. A always implies B, again false. So option 1, 3 and 4 को हमने reject कर दिया. So the only correct option which remains is option number 2. Okay. Now consider the following system of equations. Yeah. In the unknowns x1, x2, x3 with lambda being a real parameter. So ये मेरा system of equations है. Now under which of the following conditions the system has non-zero solutions? So I am basically trying to solve 1, 2, minus 2, 2, minus 1 lambda, 3, 1, minus 1 times x1, x2, x3 is equals to 0. So I am saying A equals to 0, Ax equals to 0 has non-zero solutions. So that will happen only if determinant of A is equals to 0. Okay, so if in a 3 cross 3 matrix, only one determinant A is non-zero, can you have Ax equals to 0 having non-zero solutions. Yeah. So for both positive and negative values of lambda, yeah, so इसके अंदर determinant A equals to 0 मुझे solve करना है. So let's find determinant of A. So determinant of A will be equal to 5 lambda minus 5. So you can solve this. Determinant निकालना तो आता ही है. Which implies lambda, which is 0, implies lambda must be equal to 1. So for lambda equals to 1, determinant A becomes 0, which implies that this thing has non-zero solutions. So that's your correct answer for lambda equals to 1. Okay. Now there are 4 statements. Which of the following is true? सो यहाँ पे मुझे 4 स्टेटमेंट दिए हुए हैं यहाँ पे. सो लेट्स sorry. Yeah, y is a rational number. If y is a rational number, then the set minus 200 less than equals to y less than equals to 200 is a countable set. ठीक है. So countable, uncountable sets is something which comes from cardinality of numbers. So if you do not know this topic, you can basically click the I button below above and you will be redirected to that particular topic जहाँ मैंने पढ़ाया है. Now यहाँ पे उस topic में हमने ये देखा था कि the set of rational numbers Q, first of all, natural numbers are countable. ठीक है. And rational numbers are also countable. ठीक है. And real numbers are uncountable and irrational numbers are uncountable. ठीक है. So irrationals and real numbers are uncountable. ठीक है. So the proofs we have already done. Now the first thing, y is a rational number. So the set, so ये तो rational numbers का subset हो गया. So all the rational numbers, ठीक है, in minus 200 से 200 is a subset of a countable set. So a subset of a countable set will be countable. ठीक है. So statement 1 is true. Statement true, y is m upon n where m and n are integers is a countable set. अब यहाँ पे this is not the set of rationals. What is the definition of rationals? ठीक है. Statement 2 is not basically rational numbers. Rational numbers are defined as all numbers of the format m by n such that m comma n are integers or belong to Z and n not equal to 0. Not all integers are allowed. So यहाँ पे n equals to 0 भी allow कर दिया है इन लोगों ने. So that's why this is not the definition of rational numbers. So that's why this particular statement is not true. Statement 3, y is a real number such that y is between 0 to 0.7. Now the set of real numbers is uncountable and the set of any subset of real numbers is also uncountable. Okay. So for that reason this particular statement is true. Okay. You can take any small subset 0 से लेके 10 to power minus 10. Even if you take such a small subset, it is still uncountable. ठीक है. क्योंकि countability का फंडा is not related to how large the set is. In fact, this set 0 से 0.7 has the same cardinality as the set of real numbers. You can define a 1-to-1 function going from 0 to 0.7 से लेके r. So that's why the two sets have the same cardinality. Again, coming back. Statement 4, y equals to root 2 upon n where n is a positive integer is an uncountable set. So यहाँ पे, yeah, so these are all irrational numbers, right? So this is a set of irrational numbers. Sorry, this is not regarding irrational numbers. Can you construct a 1-to-1 function going from this set 4? Let me call this as set 4. Can you go from set 4 to the set of natural numbers? Okay, so can you define a 1-to-1 function going from set 4 to the set of natural numbers? So yes, you can, right? So what is this set going to be? So this is going to be root 2 comma root 2 by 2 comma root 2 by 3 comma root 2 by 4. So you can make a 1-to-1 function. Okay, so f of root 2 is 1, f of root 2 by 2 is 2, f of root 3 by 3 root 2 by 3 is 3, f of root 2 by 4 is 4, and so on. Okay, so you can construct a 1-to-1 function from this set to the set of natural numbers. So that's why this particular set is countable. पर यहाँ पे कह रहा है कि this is uncountable. So that's why this is wrong. Alright. So because of these reasons, question number 10 में the correct answer is going to be statement 1 and 3 are correct. राइट। एक बार देख लेते हैं मैथ्स के कितने सवाल है इसमें। ऑलराइट, सो we'll do question number 10 to 15 in the next video. So thank you guys. So if you like the channel, please subscribe and do watch the next video in this playlist. Thank you.